What is mathematics the science of? Hello there, and welcome to you who understand the importance of philosophy. Today I invite you to reflect with me on the object of mathematics. Mathematics can be understood, according to Hermann Weyl, as the science of the infinite. And yet, this thesis appears only late in its history. For mathematics first becomes a science with the Greeks of antiquity. They are the ones who compile, systematize, and demonstrate the empirical results of arithmetic and geometry. This transformation is made possible by the use of philosophical logic. It allows the constitution of a deductive body of knowledge, grounded in axioms and postulates. These principles, axioms and postulates, are indemonstrable, but they are accepted as the primary conditions of all demonstration. They form the roots of the scientific edifice, without which thoughts would fall into an infinite regress. Thus, Greek mathematics becomes the paradigm of deductive science, and the entire mathematical tradition develops along these lines. In the modern period, arithmetic and geometry give way to algebra and analysis, and then to a multiplicity of disciplines that together form what we now call mathematical science. And yet, number retains a central place, historically, conceptually, and symbolically. With Pythagoras, it becomes the very principle of the universe, and thus the keystone of a universal mathematics, already conceived as the propedeutic of all philosophy. Number can then be understood as pure form, and first of all, as the form of finite multiplicities, that is, finite sets, according to Husserl's intuition. But with Cantor, a decisive shift occurs. The notion of set becomes foundational. Mathematics then finds in set theory its ultimate conceptual framework. And yet, even there, number remains. For Cantor was precisely seeking the theory of infinite numbers. Number thus appears as the form of multiplicity, whether finite or infinite. It is in this way that a rigorous theory of the infinite emerges, and within this new mathematics, number still plays a central role. For the entire theory rests on the natural numbers, described by a few simple axioms formulated by Peano. It is from them that modern mathematics is reconstructed. At the same time, modern mathematical logic emerges through the study of its own paradoxes. Arithmetic thus acquires a foundational role. This is evident in Gödel's work, but also within axiomatic set theory itself. For it rests on a fundamental principle, the axiom of infinity. This axiom affirms the existence of an infinite number. More precisely, within this framework, infinite numbers appear as ordinals, transfinite numbers defined as order types. And the theory of natural numbers itself derives from the existence of such an infinite ordinal. Thus, modern mathematics presents itself as refounded in set theory. Its core is logical, a theory of multiplicities, but its properly mathematical pillar is the infinite. From that point on, the concept of infinity becomes ubiquitous. It becomes the very criterion of mathematics. Mathematics then appears as a dialectic of the finite and the infinite, grounded in the logical theory of the one and the many. Thus, the cycle opened in antiquity comes to a close. Mathematics, first understood as the science of number, ultimately reveals itself as the science of the infinite. And this infinite, brought to light by Cantor, now illuminates not only mathematics, but also beyond it, science and philosophy.